Hi, everybody. Mary here, and this time we're going to talk about double displacement reactions. This is one of those primary types of chemical reactions, and a double displacement reaction can also be called a double replacement reaction. Same thing, same name, it just depends on who's doing the talking, what name it is going to be called. Now, double displacement reactions always are going to occur in an aqueous or water solution. And these reactions involve ions that are doing an awful lot of moving. They're swinging around and they're changing partners. The generic form for a double displacement reaction looks like this. It is AB plus CD equals AD plus CB. In my brain, I think of it as two couples on a dance floor and they are switching partners. So here we've got Minnie Mouse and Donald Duck dancing, and here we've got Daisy Duck and Mickey Mouse dancing, and the square dance master says, okay, everybody switch partners, and then they switch. So Mickey ends up with Minnie, Donald ends up with Daisy, and this is a more stable situation than it was before. That's what happens in a double displacement reaction. There is a switcheroo of ions. Now, we talked about single displacement reactions. Now we're talking about double displacement reactions, and I want to just make sure you understand that these aqueous reactions, these reactions that occur in solution, are very, very important. I know most of you taking this course are involved in the healthcare industry, and that all of these biological reactions, whether you're talking about the lymph system, the blood system, the nervous system, respiration of cells, energy production of cells, you're talking about the renal system. The human body is one big bag of water moving constantly. Solutions and fluids, energy going in and out, and all of this is a big chemical machine. And so these water aqueous reactions are a big deal. So we want you to have an understanding of the basic reaction types so that when you do take anatomy and physiology, when you go into biochemistry and organic chemistry, you have the basic chemistry, and then they can build in the physiology and the more specifics. When you have a double displacement or replacement reaction, one of the products will be either a gas, a molecular compound, or a precipitate. One of those, not all of them, but one of those. So sometimes you're going to have a gas produced. It could be hydrogen, oxygen, chlorine, carbon dioxide, or a multitude of other gases. Sometimes it's going to be a molecular compound, meaning something that was covalently bonded. Now, it could be a gas like carbon dioxide gas, so it could be both a gas and a molecular compound. Or it can sometimes be a liquid like liquid water. And sometimes it's a solid, and we call those solids precipitates. And we'll talk more about those in a moment. The other product in a double displacement reaction is going to be an ionic compound that is in solution and will be aqueous. So out the other end, one of these products is going to be either a gas, a liquid, or a solid, and the other one is going to be aqueous. That is one of the ways that you can help identify one of these double displacement reactions. Now, I use the term precipitate, and it might sound familiar to you from weather reports and meteorologists using the term precipitation. Precipitation can mean rain, it can mean snow, heck, it could mean hail falling out of the sky. But it means something that is falling from above. A precipitate in chemistry is a solid that falls out of solution in a chemical reaction. Really fun when you have a chemical lab and you produce a precipitate, because sometimes you take two clear solutions and all of a sudden you get a solid that's produced, and those solids accumulate and fall down to the bottom of the beaker. And I've collected a variety of pictures of precipitates, and they are some of the coolest chemical reactions that can exist. Now, when a double displacement reaction occurs, we often have to predict what is going to be that precipitate? So here's an example of a double displacement reaction. Potassium iodide aqueous plus lead 2 nitrate aqueous is going to produce potassium nitrate and lead iodide. Now here's the thing. First off, how do I identify it as double displacement? I've got two aqueous solutions that are mixed together. These are two ionic aqueous solutions that are mixed together. That is a big hint that you have a double displacement reaction. Out the other end, between these two, one is going to be either a gas, a molecular compound, meaning it's going to be a gas, a liquid, or a solid. So often we're going to have a precipitate, and because I set this up ahead of time, one of these is going to be a precipitate. On the back of your common ion sheet, which is one of the tables, one of the pieces of paper I asked you to print for this class, and that is available on our website, there is this table. And you use this like an old-fashioned multiplication table to determine which one of these is going to be the precipitate. And this is how it works. If I have potassium nitrate, let's see if that's going to be aqueous or precipitate. So I'm going to look up potassium. Here's potassium. And I'm going to look up nitrate. Nitrate, NO3. And I'm going to see where potassium and nitrate mix, and those go right there, and it says AQ aqueous. So potassium nitrate, when those two bond, that's aqueous. So that will not be my precipitate. Now I'm going to look at lead iodide. Lead iodide, here's my lead. Here is iodine. Here's my iodine. And when lead and iodine form a compound, it says S. S means solid. So if these two aqueous solutions bond, they produce a solid. The solid that is produced in this double displacement reaction will be lead iodide. And I included this collection of pictures because this is a series of photographs of that chemical reaction. And that two clear solutions mixed together and you get that beautiful bright yellow solid, that is lead iodide. Great chemical reaction, fun to do, fun to see done, because holy buckets, it looks like magic, not magic chemistry. Now let's take a look at another double displacement reaction and see if we can pull out all of our chemistry knowledge and predict the outcome. We've got two ionic aqueous compounds. Can we predict what's going to happen? The ions are going to do a switcheroo, like two couples on a dance floor switching. So let's take a look at what ions we have. First off, I've got sodium. Sodium is going to be an ion of +1 because it's in group 1. Carbonate, CO3, is this one, CO3 2-. Barium is group 2, so its ion is Ba+2, and chlorine is a halogen. Its most common ion is Cl-1. In a double displacement reaction, there's going to be a switcheroo. So barium's going to go with carbonate, and sodium is going to go with chloride. So what's going to happen? Well, sodium +1 is going to bond with chlorine -1. One of each is going to give me sodium chloride, and then barium +2 is going to be with carbonate -2. One of each is going to give me barium carbonate. Which one is going to be aqueous and which one is going to be my solid precipitate? I'm going to use my chart here to predict solubility. If I find sodium and chloride, here's sodium, and it says right here AQ, and we knew that salt was soluble in water, so I didn't have to look that up, but I wanted to show you that we could. And barium carbonate, here is barium. Where's my carbonate? Carbonate, where are you? Oh, somewhere here, I'm hoping there's a carbonate. Maybe, oh, there it is. barium carbonate right there, S, it is solid. That's going to be my precipitate. That is my double displacement reaction. Do you feel like a fancy chemist? Well, that's pretty high level chemistry there. I'm pretty impressed you can do that. Here's what I'd like to have you do. Hit pause, give this one a try, and we're going to go through it together. Okay, my friend, let's give this a shout. Sodium, most common ion is +1. Sulfate, most common ion is from over here. Sulfate is, I know, don't sing, Mary. Calcium is group 2, so calcium is going to be +2. Chlorine's a halogen, it's -1. When they go through double displacement, the ions switcheroo. So sodium's going to go with chlorine, calcium's going to go with sulfate. So sodium chloride, we know that one. We know that's going to be NaCl. And calcium sulfate, calcium's +2, sulfate is -2. Both are 2, so that's going to be CaSO4. We know sodium chloride is aqueous because we just did that on the previous page. Calcium sulfate, calcium is here. Sulfate is way the heck down here someplace. Sulfate, calcium sulfate is going to be a solid, and that's going to be the solid precipitate produced when this double displacement reaction occurs. And that, my friend, are double displacement reactions. All right, we will see you next time, and we'll talk about other kinds of reactions. See you later. Bye-bye.